I want to show just how quick and easy you can get a CAM application up and running inside Sysmac Studio and show you how Studio takes away the intimidation factor with CAMs. So I've got a new project here. I'm starting with an NX102, and then I also have my 1S demo here, which has a belt axis and then a lead screw axis. So I'll go ahead, create a new project, and then once that opens, I'm going to go ahead and go online with the controller right away. Now, this is a default controller IP address, so it knows automatically what IP address to use. So inside Sysmac Studio, I can go to the EtherCAT setup, and an awesome tool is I can use this compare and merge with actual network configuration. And then Sysmac Studio looks out to physically what's actually connected to your controller, and it will go ahead and map that into your project. And now that that's done, I can do the same thing on the CPU rack. I have some NX-IO cards mounted onto my NX102, and I can map those in. Now I'm going to go offline and add 2 motion axes. I'm going to call the first one, rename it to be my belt so that I can use the name belt anywhere in my program rather than the name that it's given by default. And then I'll set the second one up as screw for a lead screw. Inside the axis, I set it to a servo axis, and then I point to that particular EtherCAT node. Then I can set up my user settings. So even though this is a belt, I just want to actually treat it with 0 to 360 degrees. So I can put the 360 degrees per rev, and then 8388608 pulses per rev, because this is a 23-bit encoder. And now anytime I'm using any sort of commands or units inside my program, it's all going to be based in degrees, and I don't have to think about encoder counts ever again. Set some maximum speed and maximum jog speed that are within the acceptable range, and then I only want this to count between 0 and 360 degrees, so I'm going to set it to rotary mode, and it'll just be a sawtooth wave. And then I can do the same thing with the second axis, set it to a servo, point it to that second node, set my user units. So this time it is a 20 millimeter pitch lead screw and 8388608, and then go ahead and set some maximum velocity and maximum jog velocity. Okay. Then what I would need to do is on the left-hand side of the Multiview Explorer, I can go to CAM data settings and add a CAM profile. So it creates CAM profile 0. And then I can start adding in my nodes. So let's go out 40 millimeters at 180 degrees, and then let's come back to the starting position to 0 at 360 degrees. So a simple triangle, but that's a little harsh. So let's maybe smooth the motion out a little bit. So let's set it to parabolic. There's a number of different curve shapes that you can add in there, and then you can actually drag points around here if you would like. Okay. Now let's go into our program and start adding some motion commands. So let's add in for both axes. We need to have power commands. So we have to instantiate the function blocks. So you give the function block a name, you point it to the axis name that you're looking for, and then let's go ahead and give a command to enable power. And when you're creating variables inside Sysmac Studio, it will give them the proper data type if you are only allowed to assign it to a particular type of data. So if I'm putting in a contact, it knows that it's a Boolean data type, and it takes care of that for me already. So I'm going to call this one screw power, and then we'll point it to the screw axis. Okay. And then the other thing I want to do is for the lead screw, I might want to home it just to make sure that it is in the proper 0 position. And there are a number of different homing styles that you can use in the axis setup. The default, though, is just 0 position preset, which says wherever you're at, just define that as 0. So if you're doing a system setup, you can move it into position and then run the home routine. And if it's an absolute encoder, it'll always store that position. So now let's add 2 rungs for the master. So we were going to do a move velocity. And for this, I'm just going to call this belt velocity. And then again, we're going to point that to the belt. And for velocity, we could put a variable in here. I'll call it belt velocity, and that way we can just treat that as a variable. And then command move belt. And that will execute that so that the belt is just going to run at a constant speed. The other thing we would want to have with that to stop the belt if we ever wanted to is put in an MC stop. So we can do function block belt stop, point it to the belt, and then have a command to stop it. And we can also put in decel parameters, same thing, accel and decel, but for this demo, we're not going to be moving super fast, so I'm just going to leave those as default. So now we've got the master taken care of. Now we need to put a cam function block in. So that's the MC cam in. And this cam function block, when you put it on your ladder, it's a little intimidating because there's a lot you can do with it. Not a lot that you have to do with it, but a lot that you can do with it. So I'll give it the name. I'll point to the master saying the belt axis is going to be my master axis. The screw axis is going to be my slave axis. And this is going to follow cam profile 0 as my cam routine. And then I'm going to say command cam in. And then I actually want this cam to run continuously. So for the periodic, that you would set to true, just to say keep running. And one nice thing about inside Sysmac Studio is if you're not sure what the inputs should be, you can hit F1, and F1 will bring up the help file for that particular function block and give you all the details of how you can use and customize and what all the different inputs mean and whatnot. And then the last thing we would want is if we ever wanted to stop our cam, we would put a cam out function block in. So function block screw cam out. The slave, just give it the screw name, and then a command cam out. And we can set that as a global variable. Okay. So now let's go ahead, go online. And then we can synchronize. And when we synchronize, what it's going to do is it's going to look to see what's in the controller versus what we have in our particular project. So now it's going to look for all the differences. It's going to compare, and this is a totally new project, so it's going to download everything. So when you do the first download, it downloads the entire project. Subsequent downloads of your project, it's only going to download anything that's different. So that actually saves you a good bit of time. So while that is synchronizing, we will just wait one moment here. All right. It's finishing up the download. And then now it actually puts it into run mode. And so now we are running. So the other thing I want to do is I'm going to go ahead and put in a watch tab page. And down here at the bottom, I can put belt.actual.pause and screw.actual.pause. And those are the actual positions. And the other thing we have in here is we have the belt velocity that we have as a variable. And these numbers, the online value, you can see they're hovering right around 0. Okay, so now what I want to do is I'll hit the command power, and then, not sure if you could hear that, but if I switch over here, the servos, the drives both give that 0E indicator, which means that the servo is on. And then back on the Sysmac screen, down here in the watch window for velocity, I'm going to enter 180. So that gives me 180 degrees per second. And then if I click the command move belt, the move belt then will start jogging that belt. And if I switch back, you can see the belt moving up. You can see that white square kind of moving up like that. Okay. So now, let's go ahead and give it a cam in. So I'll give the command to cam in. And now you can see that the cam is just following based on that 0 to 360 count of the master velocity. So that quickly, we went from a new project to running a cam profile. And then if we wanted to, we could switch back. I'm going to up the speed here. So I'll enter a new speed, and then I'll execute the cam in function block, or not the cam in function block, the move velocity function block. We'll re-execute that. And now you can see that as I increase the speed, that the second axis is just following accordingly. So in a matter of about 10 minutes, we went from a completely blank project to running a cam routine. And then if I go ahead and hit the command to cam out, I've cammed out. So that quick, easy peasy, easy to work with when you've got the Sysmac Studio platform.